All right, so now let's talk a little bit about these metabolic equations. Really, I'm just going to give you the Excel sheet that I made a little while ago so that it's fairly easy for you. These metabolic equations are really good for measuring things like VO2, which, as a human, I think you should know that oxygen consumption, that's all that means, is really important to us being alive. But what we can do with these equations is we can predict how much or how many calories people burn, if people are getting better at exercise, or if we're just maintaining things. Uh, Really, the applications are just about endless. And most of this should make more sense as we go along. Hopefully, I got to talk about absolute and relative VO2 today in class, but really quickly, absolute VO2 is just the amount of oxygen that we consume in liters per minute, not controlling for our body weight. And then relative VO2 is controlling for our body weight, so it's milliliters of oxygen per kilogram of body weight per minute of activity or exercise. So what these metabolic equations are doing is we're actually getting relative VO2s from these. So I'll show you some stuff that's pretty cool. A few things that I want you to know from here is that they have a horizontal component. So if you're walking, running, or cycling, that kind of makes sense going forward, and then a vertical component. So on that, that's more or less like the incline. So there's a little bit of you can add an incline walking or running, and yeah, and then there's a resting component. So one thing to keep in mind is whenever we're at rest, we are burning calories. So that's actually baked into all these equations. So I just want you to look at that really quick. There's a lot more with this that I want you to pay attention to later. Like, for example, the vertical component of running is actually less zero point 0.9 than the vertical component of walking. And that's because whenever one is running, there's a flight phase. So we're actually not expending energy during that time. However, we go much faster whenever we run, and the horizontal component is a little bit more costly, zero point 0.2 versus zero point 0.1. So yeah, there we go. And one thing here, S, that just means speed, and G, that means grade. There's a few assumptions and limitations with this. So measured VO2 is highly reproducible at a given steady state workload. So that someone is at a steady state, they're not changing their speed all of the time. Um, Accuracy of the equations, it doesn't really matter how hot or cold it is outside. Uh, um, these equations still work relatively well. Mechanical efficiency and gait abnormalities, you don't do anything that makes your gait wildly like uneconomical or inefficient. And also assuming that their ergometers, like our cycle ergometers, our bikes, or our treadmills, are actually calibrated. So now this is going to show up here. Uh, let's look at the very first walking equation. So VO2 right here, milliliters of oxygen per kilogram body weight per minute. Here, that's the horizontal component, vertical component plus resting. This is for speeds of 1.9 to 3.7 miles per hour. I have a bunch of things entered in here for you. If you have somebody and they're exercising, you're trying to figure out how many calories that they need to burn. Let's say that they weigh 140 pounds. So that is 63 kilograms. One thing, speed, it needs to be in meters per minute, and grade is as a decimal. But I did you a solid, so speed miles per hour. Let's say they're walking at 3 miles per hour. That is 80.4 meters per second. And so 1 mile per hour is actually, you can see it right here, 26.8 meters per second. Just entered that for you. Yeah, almost messed that one up right there. That would have been bad. Grade. Let's say they're doing it on a 3% grade. You can just enter a 3 right there, and then a 0.03%. That's actually how the decimal needs to be for it to work. So if someone is doing all of this, they weigh that much, they're going that fast, and a grade of a 3, their VO2, relative VO2, is 15.8816. So they're consuming 15 or about 16 milliliters of oxygen per kilogram body weight per minute, give or take. That's predictive. VO2, they're consuming 1 liter of oxygen per minute. That's what that means. Now, down here, this shows that if you're doing this, you are burning, look right here, kilocalories per minute. So 5.04 kilocalories per minute. So let's say that they did this for 30 minutes. You'll burn 151 calories. Calories is how we talk about them. Now, that is how much we burn through exercise plus our resting metabolism. If you want to figure out how many calories you're burning just from exercise alone, I actually entered that in for you right here. So, what that is, about 3.9 calories per minute, so we almost lost one. One thing to keep in mind, humans normally burn around a calorie per minute. Larger people a little bit more, smaller people a little bit less. For 30 minutes, 117 or about 118 calories just from exercise alone. Next, I'll move on to running.